Can you see the presentation now? I hope so.
Yes, we can.
Okay, great. So as Anna just said, I work at the Institute of Oceanographic Research that's within the University of Baja California, located in Baja California in Mexico. And my talk today will be about my general research ideas. I will present the data set I have been collecting for the past years, and hopefully we'll have a discussion on this later on. So, okay, see if it works. Okay, so the motivation of my work started collecting topographic data. So when I first arrived to Ensenada, we didn't have a lot of knowledge on the morphodynamics of these beaches here. So I thought collecting topographic data would help. So this is just an example of the mean subaerial volumes for Ensenada Beach for a 6-year period. Now we have 2 more years to go. I have data to process yet. So interesting things that we can see from this data set is, for example, the high seasonality. We see large erosive events. This was the El Niño 2015-16, and then beach recovery, the recovery of the beach in the following 3 summers. So I got like this data set basically gave me the question how the exchange of sediment was between the Subaerial and subtidal beach. And so I am interested in understanding beach recovery capabilities in interannual scales. Then the effect of El Niño winters is very interesting. We captured 2 El Niños, one in 2015-16, the other one in 18-19. And something that I want to look at into detail is the mechanisms for the subaerial beach to recover. So I will first introduce our field sites, and then I will show the morphodynamics, the Sandbar morphodynamics for Ensenada Beach. It's 4 annual cross-shore migration cycles. And I will conclude on the modes of onshore sandbar migration, which is very relevant for a beach recovery perspective. So these 2 aerial images were taken with the UAVs. The upper one is Ensenada Beach. Ensenada is an embayed beach. It's located within Todos Santos Bay, which is roughly 20 kilometers wide. And then I am also looking at La Misión, which is an open beach located farther north. So I will then show some examples on the volume exchange between the subaerial and subtidal sections for these 2 sites, and finish up with some perspectives for further research. So where are we? We are located in the Eastern Pacific, in Baja California, in Mexico. This is south from the state of California in the US. So we are at a latitude of 32 degrees and longitude of minus 117, roughly. The sites they have a tidal range of 2 meters, medium sand. They are made of medium sand. They have a single subtidal sandbar. They are gently sloping. And this is a map here on the right-hand side of the coastline, the location of Ensenada Beach, which is the embayed beach, and La Misión, the open beach. The distance, it's 30 kilometers, one from the other, so they are fairly close. And these sites are exposed to offshore swell dominated by modal waves. In winter, usually between November and March, we get northwesterly waves, and in summer, we get waves from the southern hemisphere from from Australia and New Zealand. So this is a time series of the waves that we've measured in our sites. These are ADCP measurements for a 8-year period. So we have each dashed line represents each November for each year. Okay, so this is 2012, 13, and so on until 20. So this is a picture of the ADCP. We place these ADCPs at 20 meters. We don't really have offshore buoys here. We don't have NOAA like in the States. So we really need to measure the nearshore waves by ourselves. So what we see from this data set is that we have a highly seasonal wave conditions. As I said before, fairly energetic winters between November and March and calm summers. So it's a seasonal, highly seasonal waves. Something that I want to mention is that sometimes we basically place these ADCPs every, we replace them every 3 to 4 months for their batteries and so on. And sometimes we find around 50 to 60 centimeters of sand covering up the structure. And this is at 20 meters. So I have been thinking about this for a while. And this is something that I want to like kind of, we can discuss this later, but there is definitely quite a lot of sediment being moved at that depth. So we measure topographies and bathymetries now every month. We collect data, topographic profiles every 50 meters using an RTK GPS. The GNSS station is located up on the roof of my office, actually. So we post-process the data. We actually work in differential GPS mode. We walk profiles along the beach, and we collect the bathymetry using a jet ski. So basically, the jet ski has a GPS antenna and an ADCP, which has an integrated echo sounder on it. So this is really good because you can measure the depth at really shallow waters, and everything is radio linked. So all the information is sent directly to the computer. So we interpolate this data, we get DEMs, and then we look at differences to figure out whether we are getting erosion or accretion in either sites in the subaerial or subtidal beach. We can also, from the raw beach profiles, we can also extract the sandbars and look at the sandbar morphometrics and calculate volumes and shorelines and so on. So now I will first show you some results on sandbar morphodynamics for Ensenada Beach, and this will be for annual cross-shore sandbar migration cycles. I was hoping to have data processed till the present, but that's going a little bit slow at the moment. So these are 4 annual cross-shore migration cycles, and they include the effect of the El Niño 2015-16. So these are the DEMs that we obtain from interpolating cross-shore profiles for this. These are combined subaerial and subtidal DEMs. So the thick white line is the shoreline, the mean low tide level. So the upper part corresponds to the subaerial beach, the lower part is the subtidal, and now I will show the cumulative changes in time for 1 year first. So this will be September 14 to September 15. That was before El Niño. And in colors, we have accretion will be shown in warm colors and erosion in blue colors. So what we will see is that we see the sandbar forming in November, and then it will migrate offshore during the winter. And then at the end of the winter, we have onshore migration until it wells to the shoreline, usually by May. and then we will have an unbarred beach over the summer. So this will be the Sandbar now moving onshore, well into the shoreline. So the Subaerial beach fully recovers. The following year, this is cycle 2, we had the El Niño coming up. So the El Niño winter started in November 2015, and it actually finished in April 2016. So we will again see the sandbar forming in November, and it will migrate farther offshore than these 3 meters, and it won't be able to come back. So during the summer, we will have actually a terrace bar. I'm going a little bit ahead here, but I will show you that later in another figure. So this is a huge Subaerial erosion. So a huge sandbar is formed, and that's kept there over the summer. And it actually erodes and it becomes a terrace bar. So the following year, this is cycle 3. In November, we will see how this terrace bar actually turns into a sandbar, and the sandbar moves a little bit onshore. We had unusually low energy conditions during the early winter in 2016-17, which allowed actually the sandbar to migrate onshore. And then a large storm hit in late January 2017, and that will reset the beach. And then in May, we will see how that sandbar is actually splitting. One section will migrate onshore and the other one offshore. That's a reset, and that's splitting. Okay. So the following year, this will be cycle 4. The sandbar formed in December, a little bit later than in the previous years. And we will see the coexistence of that newly formed sandbar with the terrace bar that will be following a net offshore migration cycle is left behind in deeper waters. And then the newly formed sandbar will actually migrate offshore over the winter and then onshore over the summer until it couples, it welds to the shoreline, and the beach becomes unbarred in summer. That's the sandbar. That's the sandbar moving, and we have this terrace bar left behind. And we see how the this Subaerial beach recovers fairly well after this event. Okay, so okay. Oops, sorry. So this figure is the summary of these processes that I've just explained. So it's a time series of longshore average sandbar positions for the 4 years. And we have the time in the bottom of the figure between August 2014 and September 2018. So these are the 4 cycles that I've just presented. We have the monthly averaged dimensionless fall velocity, omega, and the averaged total energy flux in kilowatts per meter. And I draw like this line, dash line, for the total energy flux. And that's indicating that when it gets over 40, the value of 40 is when we have highly energetic conditions. That's the El Niño here, and then the highly energetic storm that resetted the beach. So in the upper panel, what you see is the shoreline. That's a zero contour line. This is the Subaerial beach and the subtidal beach, and each of these dots represent the sandbar, and the triangles are terrace bars. The colors for these two symbols indicate the volume that the sandbar actually has, or the terrace bar has. So we actually see that there is a cross-shore boundary that defines the capability of the beach to recover over the calm conditions in summer. So for the first cycle, the sandbar didn't cross that cross-shore boundary. While that happened during the highly energetic El Niño, the sandbar went beyond the cross-shore boundary, and so the sandbar actually wasn't able of welding to the shoreline during the summer. And that didn't happen until cycle 4, when this newly formed sandbar actually migrated offshore, but it didn't cross the cross-shore boundary, so it was actually able of migrating onshore during the calm wave conditions, and then the beach recovered. So we see the shoreline, the shape of the shoreline is actually indicating this, the recovery of kind of, it's a proxy of the recovery of the beach. So we published this year in a paper, and we basically summarized 4 modes of onshore migration for the sandbar, depending on their location, on the location of the sandbar relative to this cross-shore boundary, on its volume, and the preceding wave energy. So basically, if the sandbar is landward from the cross-shore boundary at the end of the winter, it can weld to the shoreline during the low energy conditions after a mild winter. If the winter was highly energetic, the sandbar could cross the cross-shore boundary, and so the large sandbar would actually become a terrace bar during the calm wave conditions, when very low energy conditions remained. We also saw terrace bar to sandbar, the transition from a terrace bar to sandbar, and that happened when a terrace bar of fairly large, I would say, terrace bar located near the cross-shore boundary, it turned into a sandbar during moderately energetic conditions at the beginning of the winter. And we also saw the splitting of the sandbar, and that was when a sandbar located near the cross-shore boundary with fairly amount of sand, it split during low energy conditions. So the outer part migrated offshore following a net offshore migration cycle, while the inner part actually crossed this cross-shore boundary and migrated shoreward during the low energy period. So now I will show some results on the volume exchange. This is the time series, the same time series of 4 years for the same beach. And in blue, we see subaerial volumes, and in green, we see subtidal volumes. So as you can see, they follow the same trends and opposite patterns as expected. And so we see the El Niño event happening here, and how the beach lost around, I don't know, a little bit more, like 120, I think it was, cubic meters per meter. And that volume actually went offshore and contributed to the subtidal beach. So the thing is that if we look at the total volumes, I haven't plotted here the uncertainties related to the actual topographic and bathymetric measurements. We are actually now doing that. We have a rough idea that the uncertainty is around 25 cubic meters of meter. So let's say this is like the similar amount of volume to what the uncertainty actually can indicate. So I wouldn't rely on this a lot. We have to take those values out. But there are events, there are situations at which we actually see a significant loss of volume and significant gains of volume as well. So these are some interesting aspects that we will be working on in the next months. So I will also show the same kind of results for La Mission beach. La Mission is a highly dynamic beach. As I said before, it's an open beach located in the northern 30 kilometers north from Ensenada. And this is a time series of UAV-derived Timex images between February 2017 and December 2019. And I put this figure for you to see how dynamic the beach is. This is work done by David Gracia. And so on the right-hand side, you see the subtidal beach, and these are rip currents, basically. So as you can see, during April, we see huge rip currents, the presence of huge rip currents. This is 1 kilometer, approximately. We usually fly the drone from two sides. So this is the southern side, facing facing north. But as you can see, in summer, August to September, these rip currents are much smaller, and they even disappear in some moments, and they reform again in autumn. So now I will show a cumulative differences of the evolution of La Mission beach as well. This is just a quick movie so that you can see what happens on the beach. So the blue, the white longshore line is actually the 2-meter water line. So that's like the high tide level, okay? So this beach is really dynamic, and there are a lot of things that we don't know about the morphodynamics of this beach. So this is something that I will be looking at in the next years. So basically, we get a lot of rip currents, and the sandbar also, like in Ensenada, it forms in November, usually like now, October, November, and it moves offshore and then it comes back onshore. But obviously during the onshore migration of the sandbar, we have a lot of rip currents forming, and then there is a low tide terrace also that remains for a while. So anyways, this is just a quick view of the morphodynamics of La Mission, and this is a time series of 5 years. We managed to process the data for La Mission until August last month. So we see the evolution of the subaerial beach in blue again, and subtidal beach in green, and total beach volumes are the gray bars. And this is the wave energy. So we captured 2 El Niño events, El Niño 15-16 and El Niño 18-19. And I mean, this is newly obtained data, so we haven't really looked at the El Niño 18-19 effect yet, but this is quite interesting. So in terms of energy, these are significant wave heights measured just offshore from beach. So in terms of energy, we see that the El Niño 18-19 was less energetic, but in terms of volumes, we actually see a similar volume loss. Unfortunately, we started measuring this beach right at the beginning of the El Niño 15. So I wish we could have measured a few months before. But anyways, I mean, this is the rate of volumetric change that we see. Some interesting aspects to point out is the magnitude of change is the double to what we observed in Ensenada. I mean, here we see 200 cubic meters of meter of sand moving. And some interesting things are, for example, the income of like a lot of accretion, for example, in the total volume here. Between October 18 and December 18, we see like a large input of sediment, and similar things also in other years, like for example, between September 16 and let's say December 16, we also see like an increase of total beach volume. So these are just questions that I am picking up and trying to understand. So now if we compare both, if we compare La Misión and Ensenada, these are only the times when we measured both sites. We see a similar trend, but of course the magnitude of change in La Misión is much larger. And something interesting is that total volumes don't have like much in common. Like here, for example, we see an erosive period, and that didn't happen in Ensenada. And for example, also here, an erosive period, and this is accretive. So anyways, these are just results that I am now understanding and trying to understand them. Okay. So some perspectives for further research. As I said before, I am interested into understanding the beach erosion and recovery for the El Niños 15-16 versus 18-19. Sandbar migration patterns in Ensenada, the way the sandbar responds really nicely in the cross, like we have a cross-shore dominance in the energy flag, so the sandbar basically moves back and forwards, while in La Misión we have more longshore effects. So I am interested into understanding these differences in sandbar migration patterns. And in terms of volumes, it is also really interesting to understand the drivers of the differences on the subaerial and subtidal volume exchanges, and also the mechanisms for the sediment to be transported beyond the depth of closure, and that's a question mark. So I want to thank you all for listening, and I'm open to questions. Thank you.
Thank you very much, Amaia. Tommy, are you happy to take over the questions now?
Sure, I can do that. Okay. There's none in the chat, so I'll ask a question first, and then hopefully that instills some movement. Okay. I noticed from the map at the beginning that Ensenada is quite protected from the south southerly waves that you get in the winters, was it? Have you been able to quantify the amount that hasn't been changed, comparing it with Ensenada? Like, is there, how do I answer that properly? Because you showed how in those time series at the end, there were some storms that didn't affect both the beaches the same amount by the volume loss. So was it because of the wave direction that's why some of the beaches didn't act the same?
Okay, yeah, that's a good question. I mean, usually in winter, both sides are exposed to westerlies, okay? Even though in Ensenada, waves get fully refracted, and of course they are shore normal. That also happens naturally in La Misión. So the main differences between both sides will be during the recovery period in summer. In La Misión, we get more southerlies from your winter, our summer, and these waves come really more oblique to the shoreline. So I think that enhances the formation of rip channels and, you know, these highly 3D features. And so yeah, those are definitely important differences between both sides. And also, I mean, La Mission is an open beach, so it's more exposed to the California current and mesoscale hydrodynamics. So I have a few questions like in my head, like how those sub-mesoscale maybe processes can be affecting the input of sediment from offshore. Yeah, I don't know. We ended up buying a water pump to get the ADCPs off at 20 meters because it happened quite often. So,
Cool. So they were buried. Yeah, no, that's fine.
Luckily, they don't bury, like the instrument, the head of the ADCP, it doesn't get buried, but the actual structure does.
Yeah. Okay. So Anna has put up a question. So you found that the bar splitting in Ensenada occurred on concurrent swells from south and north. Oh, sorry, what have I done? Just moved. Sorry, yeah, occurred under low energy conditions. Is this typical? How do you think you could explain it?
Yeah, we observed only once this bar splitting event. And I'm not sure if that's typical, to be honest. I mean, I wish we had more data to understand that process. And that was after the El Niño, you know, that there was a lot of sediment behind this cross-shore boundary. So that sediment kind of piled up at a moment. So the conditions weren't enough to move the whole bar onshore, so that's why it split it. But to be honest, that's a good question. I don't know. I mean, that's an interesting subject, I think, to look at. Yeah.
Cool. So we have the next question is from James, and he's asked, did you see variations of sandbar patterns after times of concurrent swells from south and north, i.e. crossed up peaky surf?
Okay. Yeah, we actually usually have concurrent swell from south and north. That's the normal, really by model, like this, the spectrum, the wave spectrum, it's a combined of both. But when I say northerly or southerly, it's the dominance of northerlies or southerlies. And even in summer here, we sometimes also have some events from the north. So that's a little bit difficult to say. No, I haven't. That's a really good question, actually. I think looking at La Mission will help to understand this question, because in La Mission, we definitely have more southerlies in summer during the onshore migration period. So that can be a really nice subject to look at, to compare both sides. In Ensenada, waves are fully refracted, so even though they may be like coming more from the south, they refract and they come shore normal, while on the other beach you have more oblique incidence. So how that affects the onshore migration patterns of the sandbar. Yeah. Mm-hmm.
Excellent. Anna's asked a second question, but I guess she's running the show, so that's okay. What about the sediment characteristics for both sides?
Yeah, they are really similar. I mean, we have they are medium sand. We've taken a lot of sediment samples. Of course, we are really behind into sediment processing the data, but they are fairly similar. I'm not sure about the sorting of the sediment along shore. Like, that's something that we have to put a little bit more attention into it. But they are silicium medium sand. Yeah.
Okay, so the next one is from Joelle, and it is regarding the sandbar migration and wave energy El Nino intensity. Are you looking at any other wave characteristics that might affect the process, such as wave direction? So I guess we've
say it again. Sandbar migration. Okay.
Sorry, it cut out there for a sec. You said something?
Whether we are looking at other wave characteristics apart from the energy.
Oh, he's actually, I think we already answered that one in the earlier with the direction of the waves, I think, yeah. Cool. The next question is Giovanni, and he's asked, has anyone ever modeled sandbar splitting? And he opens this question up to everybody as well.
Yeah, I don't know. I don't think so. I haven't seen any paper on that. Actually, there are really few things about sandbar splitting. And there was this work from in New Zealand. There is a paper about, can't remember the name. And then, no, I mean, I don't know. I'm not aware of, but we can discuss that.
I'm also not aware. I'm just asking if anyone has heard or seen anything like that, because I haven't seen anyone. It seems like a pretty complicated thing to do.
The only thing that I've seen is from Gert Masselink and Tim Price's group in Utrecht. They call them spores, shoreline propagating accretionally waves. So that's maybe something to look at. I don't think they've modelled it though.
Yes, actually, in our paper we acknowledge their work on the spores, but not in a like a that's not for single sandbars, right? I don't know.
And the next question is from Mike Kinsella, who's our talk speaker next time. And he's asked, is there any long-term trend in shoreline change at Ensenada, historical or geological?
Unfortunately, there have been, at the university, there have been for many years coastal topography lecture, and they've been collecting data for many decades. But unfortunately, these data haven't been properly georeferenced. So that was like the typical class on beach topography, and they were collecting data for different longshore locations. But they are not properly georeferenced. So we don't have, like, I am still hoping at some point to be able to record the data, but I don't think that's going to be possible, to be honest. And no, I mean, there are a few aerial photos taken, but not like proper time series of shoreline changes. I am actually hoping to get some idea with Killian's method and maybe to compare our trends to that data set, so that at least we have some historical input from in that way.
Excellent. Okay. Oh, he's just added extra that it's a fascinating site. It looks like the opposite pair to Disaster Bay in New South Wales, Australia. So now I'll open up the floor to if anybody else would like to ask a question or comment or anything like that. Still got a bit of time to go.
I may as well ask a question then. Great talk, Amaia. Just a question about I think you identified the 3 meter contour as some kind of critical cutoff between whether the bar's going to recover, go landwards or seawards. Do you have like a morphological kind of description why 3 meters?
That cross-shore boundary, you say?
Yeah.
I mean, that has to be with the energy that we get here, no? Like the capabilities of the beach to move the sediment onshore. I actually want to look at the other side to La Mission and see whether we have the same depth, because that's much more energetic. So yeah, that's a good question. I actually also wonder why I have to look into that more into detail. Yeah, to see if we can generalize that depth.
A video question. Just regarding the burial of the ADCP again, did you have any theories on what processes might be leading to it? So it gets buried and exhumed, or it just gradually becomes buried and you have to dig it out?
Yeah, I think I'm gonna put a camera there or something. Or maybe an OBS, at least I would like to put like a chain of, like a profile of OBSs or thermistors. I don't know. I mean, these can be internal waves. I don't know. We have a lot of stratification here, and I need to talk to my colleagues, the oceanographers, and see where we can get some ideas together.
Yeah, and was that at both sites or only one site?
Usually in La Mission, usually in the open site. We do also have a little bit inside the bay. I need to look into the events particularly and see if we can connect them. Yeah, I don't know.
Yeah, no, it's really interesting. In a few weeks, I'll be talking about shoreface stuff on the New South Wales coast. And I noticed La Mission is a very sort of open stretch of coast. And some of the things we're finding on the lower shore face inner shelf are, sand ridges that are driven by alongshore currents. So wind-driven currents, East Australian current. We're looking into that at the moment, but it might be a similar case that there might be sand ridges out there that are sort of migrating and pass through your ADCP and bury it from time to time.
Mm-hmm. Yes, actually, looking at the time series, they seem to happen in the same periods in the year. So now I got really excited into looking into that.
Yeah, it'd be good to chat further offline.
Yeah.
Fascinating sites, yeah.
Mm-hmm.
Okay, any other questions? No? Okay, so before going, there are a couple of things. First, I want to acknowledge that Amaia has been our first speaker who said that she was going to talk for 30 to 40 minutes and actually talking for 30 to 40 minutes. So thank you, Amaia. We'll surprise your way. And then the other thing is ICC is happening online now. I don't know if, Ian, would you like to tell us how is it working and something about it? Sorry to put you on the spot.
That's me, huh? Oh, thank you, Anna. So first of all, I'd like to just remind everybody that ICC is happening in Sydney in 2022, and that is going ahead. And so the Sydney conference is very much live and happening, and we're pretty comfortable that July 2022 looks like a realistic time for this community to get together again and celebrate and tell each other about their science. But in the interim, the decision was to have a virtual ICCE associated with no particular country to give people who have research to talk about this year the opportunity to present that research. A very low registration fee. It's actually being run out of the United States to keep some distance from Sydney. $100 to present, and in fact to attend is free, and you can join anytime. So just search for virtual ICCE. You'll find it online. You can register. It's free to register. There are now more than 1,000 people who have registered to attend, and there'll be lots of pre-recorded presentations with the opportunity to actually talk to the authors after those presentations. So come along, but also pop in your diary for July 2022 to come and see us in Sydney. Thanks, Anna.
You're welcome. Okay, so did I say that it was happening this week? No, it isn't. It will happen soon.
2 weeks. It's 2 weeks' time. 2 weeks' time is the virtual ICCE.
Yeah, and that's why we cannot have Mike's presentation on that week. That's why Mike's presentation will be in 3 weeks instead of 2. So anyway, okay, so that's pretty much everything from me. Thank you very much, Amaia, and thank you everyone for attending, and please join me in saying thank you.
Thank you.
Thank you, Amaia.
Thanks.